Hello and welcome everybody to CyberMath's MathCounts Video Series. So our first video is going to be covering arithmetic in word problems, and we'll gradually be progressing through the kinds of topics that appear on MathCounts tests. But first of all, a little bit about myself. Who am I? My name is Alex. I'm one of the instructors at CyberMath Academy. I'm in my final year at UC Berkeley as an undergrad math major. My favorite areas of math are combinatorics, number theory, and just discrete math in general. I've been teaching at contest camps since the summer of 2019. I've actually been teaching at CyberMath since then. CyberMath was actually a first official camp I taught at, and what I'm probably most proud of and what I would consider as a hobby, I love writing problems for a wide variety of purposes. So what this video series is going to be is a series of about 3 to 4 minute videos, which each cover a specific topic or a specific formula that'll be extremely helpful in a MathCounts test, right? And in each of these videos, we'll be going over a couple of examples based on some topics, and accompanying these examples will be exercises that'll be part of integrated into the CyberMath course. So you'll have to pay for access to those. And these will be practice problems to essentially solidify your understanding, and we'll probably have some sort of feedback system. But before we get started, just there's some legal content right here, I suppose. So you can pause the video if you want to read that. But all right, without further ado, let's get started with our video series. So arithmetic in word problems. This is going to be our first example. And some of these are inspired by past problems, from MathCounts, some from other sources. So first example. At the crack of dawn in Texas at 5 a.m., the temperature was -2 degrees Fahrenheit, but later that day at 1 p.m., it was 5 degrees Fahrenheit. And the question wants us to find how many degrees warmer it got between those two times. All right, so this looks like a perfect example for subtraction, right? Just looking at this problem, we're thinking, how do we find the difference between these two values? Well, we subtract. We have -2 and 5, right? So we want to subtract the -2 from the 5 and not the other way around, because we're getting warmer and not cooler. So let's draw a number line, right? So this is probably the best way to represent some kind of change in some quantity like this, right? So we're dealing with values that are like -5 and 2. So if we just make marks along the number line to look like this, we can say this is like -5, -4, -3, -2, and you get the picture. You can fill in sort of what those should be. So 1, 2, 3, 4, and we're being asked to find how many degrees warmer it got. So that would be 1, 2, 3, 4, 5, 6, 7, right? So this is 7. If we're just subtracting 2 and -5, right? Or sorry, was it -2 and 5? Well, either way, I guess we can kind of do with this example, right? 2 minus -5. This is a pretty common example of subtraction, subtracting negative integers. And this is often a point of confusion, because how does one subtract a negative integer? Well, we can think of this as like a common analogy, like sort of credit and debt, right? Where 0 is just a neutral state. Going in the positive means you have money, right? And being in the negative means you owe money. If you're subtracting some quantity like 2 minus 5, that would mean you have $2 and you're going 5 backwards. You're effectively paying $5, which means you'd then be $3 in debt, right? So you'd be at -3. But what if you go the other way around? What if you start at 2 and then you want to go -5? Well, a handy way to think of this is just inverting the direction. You're going in the number line. So like if you're subtracting a negative, that means you're actually going positive. So with this sort of monetary analogy, right? What does that mean? It means you're paying someone -$5. Well, if let's pretend I'm paying you $1, right? Now, if I were to pay you nothing at all, I'd be how much richer? I'd be $1 richer. So naturally, kind of extrapolating from that, if I were to pay you -$1, how much richer would I be? $2 than had I paid you $1, right? And you can kind of keep going like that. So if you subtract -5, if I'm paying you -$5, in other words, I'd be $5 richer than had I paid you nothing at all. So this is actually 2 plus 5. And it looks like the example back there was actually -2 and 5. So I should probably draw another increment on the number line. And this is the same result. It's just 5 minus -2, which is going to be 5 plus 2, which is 7. All right, so you may be thinking, okay, that was a pretty rudimentary example. But mind you, we're just getting started. And in fact, the solution I wrote here is just a subtraction, but I wanted to actually go through and kind of elaborate on why subtracting a negative should intuitively make sense as a positive, as addition, because that it often is a point of confusion when you're first studying subtraction and you're thinking, how is it possible to subtract a negative? Because how do you take a negative number of things away from what you have? I mean, realistically, like in real life, you can't take away -2 apples, but it turns into an addition, right? So here's our second example. Francis has 3 coins and Gwen has half of 20 coins. We want to find how many more coins that Gwen has than Francis. So natural question, right? This is another subtraction problem because it's how many more coins. So this is a subtraction problem. Now, obviously, we want to know how many coins does Gwen have? What's half of 20? So this is kind of like a fraction problem, actually, because we're dividing 20 by 2. Half is divided by 2. The next thing in our video series is going to be fractions and percentages, but that may be a bit of a review to some of you, but just for completeness, right? Half of 20, 20 divided by 2, right? In other words, what number times 2 is 20? Well, that's 10, right? So Gwen has 10 coins, and then 10 minus 3 is 7. So I think that was a lot shorter than the other one, being honest. So, I think we have time for one more example, right? And again, you can use the number line for this if you wanted to. 10 minus 3, you just go 3 back. Some of the reason I mentioned this explicitly is because some of the math counts problems actually do use number lines as part of the problem. And then they may ask you something like, what number do you get when you go 3 backwards along this number line, or 5 forwards, or something like that? But it's just a good way to think of it, especially for something like subtracting a negative. Now, one final example. This one is, again, sort of like a ratio problem, a fraction problem. So we're given that a dollar bill is 6.14 inches long. And by the way, this also doubles as a decimal problem. And a bottle cap, like a water bottle cap, is 1.23 inches long. I don't know if these are exact measurements. I just made these up when I was writing these. So how many times as long as a bottle cap is a dollar bill? This is important, right? Always remember to read the instructions in problems, any problems, not just math counts, but any sort of math competition problem you're given, because sometimes they give you special instructions like round your answer to the nearest whole number, or express your answer as a common fraction, or express your answer in simplest radical form, or express your answer as a common fraction in simplest radical form. That's a common one. But here we're being asked to round to the nearest whole number, right? So we're all familiar with what round does to non-integers, right? So like 4.6 would round to 5, round up. Anything that's 0.5 or greater, you round up, and anything that's less than 0.5, strictly less, you round down. So 4.5 would still round to 5, but 4.499 would round down to 4. And it doesn't really matter how many 9s you have, it'll still round down, although this does give rise to the whole debate of 0.9999 repeating infinitely. Is that 1 or not? I mean, it's well established that it is 1, but anyway, that's probably neither here nor there. So the point is we want to round up if we're greater than or equal to 0.5, and down otherwise. So 6.14 and 1.23, how many times as long? What does that mean? What are they asking us to do? What operation should we be doing to figure out this answer? We should divide, right? Because we're trying to multiply the 1.23 by something to get 6.14. 1.23. I know this is kind of not MathCounts-y notation, right? But 1.23 times the thing we're trying to figure out, rounded to the nearest whole number, equals 6.14. Now, division being the inverse, the reverse multiplication operation, right? We're dividing by 1.23 on both sides. That'll give us the value of this question mark guy, right? So we'll divide the 6.14 by 1.23 as well, and it'll give us question mark. So 6.14, this is very close to 6, right? The 6.14. We'll just pretend this is a 6, and we'll also pretend this is a 1.2. Now, 1.2, that's, if you move the decimal point one place to the right, you get 12, right? So it's 12 divided by 10. And this is really an exercise in dividing by fractions, which we'll actually cover in the next video. But if you know how to divide fractions, it's going to be 6 times 10 divided by 12. 6 divided by 12 is a half. 10 divided by 2 is 5. So this is not equal to, but it's just approximately 5, right? So the answer should be 5. And how do we know it's 5 and not 4 or 6? Because let's just work backwards, right? 1.23 times 5. Well, what is 1 times 5? That's just 5. Now, 0.23 times 5, it's kind of like 23 times 5, except you move the decimal point 2 places to the left, right? 23 times 5 you can work out as 115. So you're going to get 1.15, and you add that to 5, and then you get 1.23 times 5 is 6.15. So we're very, very, very close. And this difference of like 0.01 basically doesn't matter. So our answer is going to be 5. And indeed, we check that, yep, the answer is 5, right? It doesn't matter because 1's kind of dwarfed in comparison to the rest of, like, half of 1, 2, 3. In order for it to round down, you'd have to have like 615 minus 61.5, right? So that's the general idea. Okay, so in this first video in our video series, we've gone over some examples of addition, subtraction, multiplication, division, arithmetic. Basically, that would be very similar to something that would show up on a MathCounts test in like the first 5 of Sprint. Usually, you can usually expect those in the first 5 of sprints or of like a school or a chapter round. So that's a good exercise in sort of working through arithmetic and word problems. And speaking of exercises, as I mentioned in the beginning of the video, we'll be having paid exercises that accompany the course. These will be publicly accessible, available for free, these videos, but the exercises won't be. And you'll have to register for the course for those. So until next time, take care, everybody. Have a good one.